Hi everyone, I'm Pravalika. My NAU ID is TN567. In this video, I'm going to explain about hash tables in C++. While coming to hash tables are nothing but data structures which are used to map our keys to values by using a hash function. This hash function is used to find an index where the value is stored in an array. Um, this is the example of a hash table where the keys are ABC, which are placed at indices 1, 3, and 6. Well, coming to the importance of hash tables are known for their efficiency. Um, they provide fast insertion, deletion, and lookup operations, which have a time complexity of a big O of 1. They are also known for their versatility, uh, since they can handle various types of data from strings to complex objects. They can also handle collisions, which occurs when two keys hash to the same index. They're also known for their scalability. They can scale well with large data sets, which makes them suitable for accessing applications with a large amount of data. Well, coming to the use cases of hash tables in real world scenario, they are used in databases for quick data retrieval using the index data. They are also used in caches um, to store the frequently accessed data for quick retrieval. They are also used in compilers to store the information about variables, functions, and objects. They are also used in programming languages such as Python to implement the dictionaries, which allows fast data access. So, the above are the importance of a hash table and their use cases in real world scenarios. While coming to direct access tables are nothing but data structures that uses an array to store the values with each key directly used as an index. While coming to the mechanism used in direct access trees, the key directly correspond to specific position in array, which makes data retrieval to be immediate. The size of the array in direct access tree is also fixed based on the range of possible keys. They are also simple and easy to understand since they use a simple array. While coming to the limitations of direct access trees over hash tables, uh, they can direct access trees use a lot of memory. The key range is large because they allocate space for every possible key. The range of keys must be known and should not be too large, or the array will be huge based on the range of keys. Also, direct access trees do not scale well with the large data sets with large range of keys. The array should also be initialized, uh, which takes a lot of time if the key range is very large. They are also inefficient with the dynamic data sets where keys are frequently added and removed because the array size is fixed. While coming to the advantages of hash tables, they are memory efficient, flexible, and handles collisions well. And they are also efficient with the dynamic data sets, which ensures efficient use of memory and improving the performance. So these are the limitations of the about direct access trees and limitations of direct access trees over hash tables. While coming to collisions only happen when two keys hash into the same index in a hash table. They are also said to be inevitable since uh, even with a good hash function, they are said to be inevitable. especially if they have a large number of keys. We need collision resolution techniques to manage the collisions and ensure data integrity. One of such collision resolution technique is linear probing. In linear probing, if a collision occurs, we check the next slot in the array until we find an empty slot, empty one, where we can place the key in the empty slot. Linear probing follows sequential search strategy, um, continuing in a linear fashion from the point of collision. Um, this is the implementation of linear probing in C++. Uh, Firstly, we created a hash function to calculate the index where the key to be has to be placed. If the slot at the calculated index is already occupied, we keep checking for the next slot until we find an empty slot. Well, coming to the advantages, it is simple to implement and easy to understand. And coming to disadvantages, they lead to longer search times when group of sequential slots are already filled. Welcome. And we have another collision resolution technique, which is quadratic probing. Um, Coming to quadratic probing, it checks slots at intervals that are quadratic distances away from the original hash. They use a non-linear search strategy to find the empty slot to place the key by spreading out the keys more evenly. Well, coming to the implementation, this is the implementation of a quadratic probing, where we also use a hash function. Um, when a collision occurs, instead of checking if the next slot is empty, we check slots that are increasingly far away in a quadratic sequence, which will also help spread out the keys more evenly and reduce the clustering. Well, coming to the advantages of quadratic probing, it reduces clustering when compared to linear probing. It also distributes keys the more evenly. Uh, Coming to the disadvantages, it is more complex to implement. Also requires careful handling to avoid infinite loops when table reaches the full capacity.